Alright, I drew this little scene, then started working, and then I realized I was doing it wrong, made a mistake. But anyways, definition of the derivative to the product rule.
Integration by parts.
The definition of the derivative is if there's a function p of x, and p of x is well behaved, then the derivative of p prime of x, equals the limit as delta x approaches 0 of p of x plus delta x minus p of x all over delta x. Now let's say there are two more well-behaved functions, f of x and g of x. And let's say p of x equals f of x times g of x. P of x is the product of f and g. Then, applying these two, the definition of the derivative and the definition of p, we get p prime of x. P prime of x equals the limit as delta x approaches 0 of f of x plus delta x times g of x plus delta x minus f of x times g of x all over delta x. Now in this case, we're going to want to do some algebra on this, which will probably mean either multiplying by 1 or adding 0. In this case, we're adding 0. So, okay, we're going to add f of x plus delta x times g of x and subtract f of x plus delta x times g of x in the numerator. So this is 0. So now we have the derivative of p of x equals the limit as delta x approaches 0 of f of x plus delta x times g of x plus delta x minus f of x times g of x plus f of x times delta x times g of x minus f of x times delta x times g of x all over delta x. And this equals first we're going to factor out this first g of x from here and here to go here, and then we're going to factor out this f of x plus delta x from here and here. And this is all still over delta x. Okay, here we are. We now have this expression here, which has factored out g of x and f of x plus delta x from these two other expressions. Okay, we can continue splitting this up into limits applied to each section and split up the fraction along the sum. That went out of field of view a little bit, but now we have this. So we split it up into limits applied to each term that has a delta x. Here goes to here, and f of x plus delta x is applied here and here. And you can probably recognize this is the derivative of f of x, and this is the derivative of g of x. We can just apply the derivative directly here. This is just f of x plus delta x. Apply the limit. Applying the limit here just returns f of x. So then we have, and here it is, the product rule that we all know and love. I guess I should add this equals, just to be clear, equals the derivative of p of x, which equals the derivative of f of x times g of x. Okay, now going forward, I'm going to stop explicitly writing the dependent variables, so I'll just be writing g, f, and so on. They'll just be implicitly functions of x. Okay, so we have g f prime plus f g prime equals f g prime. Maybe that's abusive notation, but whatever. This is what we just got right here. And let's see what we can get from there. Take the integral of both sides, where the prime notation in the parentheses, I don't know if this is standard notation, but we'll denote the derivative like d dx in the beginning. So this is taking the integral of both sides. This immediately cancels out, so we have the antiderivative and the derivative. There's also a plus c in there, which we will ignore. This becomes, we can subtract one of these expressions from the left side of the equation to get the integral of g f prime dx equals fg minus the integral of f g prime dx. And this is the
Integration by parts.
Let's check this answer by using
Integration by parts.
on an expression and then using the product rule to reverse it and see if we end up with the same starting expression. What is the integral of x sine x dx? It says the integral of g and the derivative of f, so let's choose a g and f appropriately. Choose f prime equals sine of x, g equals x, that means f equals antiderivative negative cosine x, and g prime equals 1. Fg, f is negative cos x, g is x, plus the integral of fg prime. F is negative cos x, g prime is 1, so we have plus the integral of cos x dx, which simply equals negative x cosine x plus sine x plus c. Okay, so this is the answer for the indefinite integral of x sine x dx right here. Now let's test if this is correct by then taking the derivative of this with the product rule. Okay, so what is the derivative of sine x minus x cos x plus c? This equals, just expanding it out, equals the derivative of sine of x minus the derivative of x cosine x plus the derivative of the constant, which equals cosine x minus, from the product rule, the derivative of x cosine x equals x times negative sine x plus 1 times cosine x, and then add that to 0. This equals cosine x plus x sine x minus cosine x, these cancel, equals x sine x. Okay, so it seems to work. Very good.